Well, so when we left off, I talked through cloud services, talked about how we could go in and build a service, add some roles into it, publish it up into the cloud. We saw that work, etc. And again, as we go back and talk about cloud services and this platform as a service model, I talked about how a key aspect of that in Windows Azure is that your cloud services, or more specifically the virtual machines that run in them, are stateless. And that's a good thing. Right? That means that if a VM crashes, Azure can just redeploy your code to a new VM and keep you running. Right? That's fantastic. And we don't have to go, perform some, autopsy on our VMs to try and pull our data out of them or something like that. It does mean, though, that when you create cloud services, you do not want to rely on data inside your role. You don't want to put data on the C drive or something like that you expect to be able to get back later. We do have a concept of local storage. Sometimes you might want to retrieve some data that's maybe expensive to get and pull it down into your web role or something like that, and maybe cache it locally so you can just read it from there. But you always know that if for some reason the local cache disappeared, you could just always go back to the source and retrieve the data again. Right, so local storage in a web role is great for web or worker roles. Sorry, is great for sort of a side cache or something that you want to use, but it's not for persistent data. And that means that anything that you expect to keep long term needs to not be inside the role, but instead kept somewhere else. And in Windows Azure, we give you a couple of different somewhere else's that you could use. One of them is our family of storage services. Or we also have Azure SQL databases that you could use. So if you want a relational structure, Azure SQL database is a good way to go. If you want something that is maybe not as structured as a SQL database, we have Azure Table Storage for sort of a NoSQL-y type of property value store. Or we also have Blob Storage, which is kind of like a file system in the cloud, if you will. Along with Table and Blob Storage, our storage services also include this really cool first in, first out queuing service that you can use as well. But that's not for persistent storage, that's for transient messages. Long-term storage would be tables, blobs, or Azure SQL. There is actually a third choice for that, and we'll come back and look at virtual machines later on, but we do have persistent virtual machines. That could run a service of whatever you wanted in them, including a full SQL install, not an Azure SQL install, or regular file services or whatever out there as well. So that would be sort of a third, more custom choice, but creating an Azure VM that you use for persistent storage, because those VMs are also persistent, right? But so that means that with Azure Storage, we really have these three flavors of storage: blobs, tables, and queues. And if I jump back over to my management portal, over here on the left-hand side is my storage set of services, right? And any one storage account has within it all three storage types: blobs, tables, and queues. And you'll notice that I have three storage accounts right now. That means that in this storage account, I've got table storage, queue storage, blob storage. In this one, same thing. Tables, queues, and blobs. This one down here as well. Tables, queues, and blobs, right? So why would I have multiple accounts, right? Your account is going to be a security boundary, right? You're going to get a set of keys that applications need to be able to interact with that storage account. So you might have different data that has different client access requirements. So you might want to separate that storage out so that some tables are available to these clients, but other tables are available to other client applications, right? So security might be one reason why. The other reason is the total amount of storage that you're going to have. And that's that any one storage account in aggregate across tables, blobs, and queues can't exceed 100 terabytes. That's a lot of data. Most of us aren't going to have that problem. But if you're going to exceed 100 terabytes of storage in a single account, then you need to have multiple accounts and segment the data up across those, right? And then finally, the third reason would be billing relationship. You might actually have multiple subscriptions. Maybe you have a subscription that you use for dev, but then there's the company's subscription that we use for the production stuff. And so I might want to have an account for myself, for my dev subscription, but I might also have access to the corporate account, and I want to make sure that I can keep that storage separate, and et cetera, out there. So there's a few reasons to have separate storage accounts. Now I can create a new storage account really easily just by coming down to the New button, and under the storage over here, pick storage. Notice I also have SQL, or if you have SQL, you can also do SQL reporting. But I'm going to do storage and just quick create. Now your storage account gets a name. Remember my cloud service had a name, and it was .cloudapp.net was the fully qualified domain name part of that. Your storage accounts are going to have a similar sort of automatic end to them, right? So I'm going to come up with a name. Let's go ahead and call this Cloud Shop Storage or something like that, right? And really? Oh, sorry. Field can only contain lowercase letters and numbers. Sorry, I forgot about that. On our storage accounts, Cloud Shop Storage. And it's going to go validate that. Okay, good. Nobody else has that name, right? So that green little check mark lets me know everything's good. Now, that's going to be the host name portion of my fully qualified domain name for each of the 3 RESTful services, Blob, Table, and Queue, right? So I'm going to have cloudshopstorage.blob.core.windows.net. And that's going to be the fully qualified host name to the RESTful API that gives me access to my Blob storage. I'll have another one, cloudshopstorage.table.core.windows.net and .q.core.windows.net. And that's going to be the URIs. Right? Again, I get to choose where my data is going to be stored. So with Azure Storage Services, you're going to pick your parent data center. Now, my cloud service is in the West US. So if I'm going to use the storage from that same service, I probably ought to have the storage in the same data center, right? And that's going to just reduce latency, and everything's going to be happier that way, right? Keep your data by your code. So I'll keep it in the West US. And I personally have multiple subscriptions, so I get to pick which subscription, which billing relationship with Microsoft I want this account to be created in. And I'm going to use this Azure demo one that Microsoft gave me. But, and this question came up earlier, but enable geo-replication. Notice that is on by default. And if you go through the Azure pricing calculator, the pricing that you look at includes geo-replication, all right? So you can turn it off and make it cheaper if you want to, but typically you don't want that. The idea is that anything that you store in storage is replicated in triplicate in your data center. Right? So that means that all of your tables, all of your blobs, all of your queues are, well, actually tables and blobs are replicated in triplicate inside the current data center. But they're also geo-replicated to the sister data center. So if I'm west, my sister's east. If I'm in north, my sister's south. If I'm in Europe, my sister's the other Europe data center. And if I'm in Asia, my sister's the other Asia data center, right? That automatically geo-replicated, and then when it gets to the other data center, it's replicated in triplicate there as well. So by default, you have 6 copies of all of your data that you keep in our storage services. So that's really cool, all right? So I'm going to leave that on. That's probably something I want, and it's already built into the pricing I expect. So I'll go ahead and say, create the storage account for me. And this shouldn't take too long, but a few seconds back there. And let me jump back over here. I talked about blobs, tables, and queues. So what are they? Blob, I said, it's kind of like a file system in the cloud. It gives you a way to put binary data or binary large objects, blobs, up into our storage services. Each blob that you stick in there is going to have a distinct URL that you can use to access that. And that blob could be public. So you might actually put like the images for your website into blob storage, and they're publicly accessible. People don't have to authenticate against the storage services to retrieve those blobs. Or they might be private, where they require keyed access into those blobs. They can also be distributed with our CDN. So on blob storage, you can enable the CDN on what we call a container. Think of that as kind of like a folder, right? And so we can say, hey, yeah, this container needs to have its content distributed on our content distribution network. Now you'll pay for that. There's a charge for that service, but it gives you a way to get your media distributed out across our CDN nodes around the world. So that's really awesome. Tables, I mentioned, are sort of this NoSQL-y sort of property value store. So if you'd like to have a way to store data with inserts, updates, and deletes and query it with selects, table storage is great, but it's not relational like a relational database would be, and it's not transactional like a SQL database would need. If you need transactional relational stuff, that's when you start looking at Azure SQL instead. But from a price perspective, table storage, significantly less expensive than Azure SQL is, right? So if you don't need SQL database, table storage is awesome. It's really cheap, right? And then queues, I mentioned, are these first in, first out messages. And we'll come back and take a look at both tables and queues here as I demo through this.
What about drives and queues?
So I skip it on purpose. Drives is not a storage type. Drives is a kind of a blob, right? Drives is a way for me to basically take a virtual hard disk and stick it as a blob up into Azure storage, right? And then the things that run in Azure that are virtual machines can attach to that VHD. All right, and they give me a way to basically create, going back to the persistence thing, I said your cloud VMs are not persistent. Well, I could actually attach an Azure drive that is persistent up to like my cloud service or something, or to my web role or something like that. And then when it's shut down, but then I have this whole problem of what if there's two copies of the web front end running? How do they talk to the same drive? And you have to do like read-only leases or things like that. So they're available. We see them a lot more when we get into Azure VMs, so I'll come back to them. We'll talk about attached drives with Azure VMs. But I'm kind of, this is a slide, the content came from corporate. I don't like talking about drives because it's not one of the storage types. It's a way to use blobs to do something, right? But they aren't actually a storage flavor. All right. So blob storage, I mentioned, again, this highly available, scalable, secure file system. They're exposed publicly or privately over HTTP. They get geo-replicated and also can be distributed over our CDN there. Let me jump back over here. This guy should have created now. So I see my Cloud Shop storage created. Let me click into there. And you'll notice the three services, blobs, tables, and queues. And I can see the RESTful API endpoints that client applications could consume to talk to those three distinct services, right? So maybe you just want blobs. That's fine. Just don't use the tables and queues. Or maybe you just want tables. Fine. Don't use the other ones, right? So you can pick and choose what you want. Remember, in aggregate across those three services, any one storage account caps out at 100 terabytes. So you want to be respectful of that. But otherwise, this is the API I would go to hit blobs. This is, or the endpoint for blobs, the endpoint for tables, the endpoint for queues. All right. So back over here, then, if you think about that, with a blob account, then you've got your account. In my case, it was the Contoso storage, or sorry, not Contoso. I'm looking at the slide, but the Cloud Shop storage, right, was the name of my account. And then within there, you're going to have one or more containers. So think of your storage account, it's kind of like the drive, right? Off the root of your drive, you could have some folders. And so that's what containers are. Containers are root level folders inside your blob storage account. You can't have subfolders underneath a container, right? So your containers are only one level deep in there. But you can have as many containers off the root as you like. And that, again, would be maybe I have one container for pictures, and I have another container for sounds, and I have another container for drives, or whatever you want to have out there. Into the container, then, you're going to create blobs. And those could be any binary data you want to store, right? They could be pictures, sound files, media files, documents, text files, something you make up. I don't know, whatever, right? They're your place to stick data. And each blob is going to have a name, right? And typically identified, with a file extension or something like that, but again, not required. Now, your name could be something ugly, right? So let's say that I had a container called pics, or we'll say pictures, but I really wanted to have like a subfolder under pictures for family or something like that. Well, the funny thing about blob names is that they can include a /, right? And the Blob API gives you a way to sort of treat those complex names kind of like subfolders, but they aren't really, right? They're all just blobs in the same depth, but Bret.jpg or something like that. So the name of the blob is really family/Bret.jpg. But the API gives me a way to sort of treat family like a subfolder and then just get things that are in that subfolder, and that kind of parses the name out for you. But it's an API trick, not really a feature of blob storage itself, right? But inside the blob then, any one blob is broken down into either box or pages. And so there's different flavors of blobs that you can store depending on how it is that you want to access them. If you're going to stream them, you might like to store them one way, versus if you're going to randomly access them, you might prefer to store them another way. So there's a couple of different APIs for that. The URL then is going to be http:// whatever your account name is, .blob.core.windows.net. So in my case, cloudshopstorage.blob.core.windows.net, and then / the container name / the blob name. And that's going to be the URL down to your blob. The question came around encryption, basically, of the data. We don't offer encryption of the data itself. If you want to encrypt it, you ship us encrypted data, and we'll store whatever bits you give us. That's the way we store it, right? So you're responsible for encrypting the stored data. Now, for the transfer of the data, you can use HTTPS to encrypt over the wire data if you want to, but we don't do any encryption of the storage of the data. That's up to you. All right. And then I showed you then that we basically have access into this through the management portal. And part of that, again, going back to security for private data, is these keys. So down here at the bottom of my account, there's this manage keys. And I see that I have a primary and a secondary access key. Now, these are the API keys that client applications need to provide as they want to connect into my storage account. They'll have to know one of those two keys. Both keys offer the same level of access. The reason we have two, though, is so that you could use one. So you say, let's use the primary one, but then maybe you feel like, we've been using that key for a while. Maybe it's been, compromised somehow. We can switch our client apps over to use the second API key, and then we can change the first one, right? So it gives you a way to sort of roll through these key changes. So you always have at least one that's valid, and you can change and cycle them out and go to the next one then. So, and then it shows my storage account name. But I can always come into Manage Keys, and then this nice little icon over here gives me a handy way to, first of all, I'll tell the browser to allow clipboard access, but it'll copy that key into the clipboard for me if I need to go paste that into my source code somewhere. All right. So there's that. Azure drives, I mentioned then, are really just a special use case of a blob, where the blob itself is just a VHD. It's a virtual hard drive formatted as NTFS, and then you can attach that other places where VHDs are expected. And again, we'll come back and see those a little bit later on when we look at VMs. So table storage then is the other, or is one of the other storage account types. And so with table storage, you can create one or more tables inside your account. So these might be similar to tables that you would think about creating in a database, but again, there's not relations between them. In fact, any one table does not have a fixed schema. You could have completely different data in every entity or every row that you stuck into that table. One row could be a car, the other one could be a fruit, right? One row could be a car with 10 columns, the other one could be a car with 20 columns, right? So no structure of the data itself, which is a very popular sort of, there's this whole NoSQL sort of subset of storage methodologies out there, and this sort of fits in nicely with those. So you're going to have inside your account one or more tables, and then inside those tables you'll have one or more entities. Now your entities need to have a partition key and a primary key, basically, or a row key. And that's the partition key helps it make sure that all data that has the same partition key is kept physically adjacent to each other. And then the row key or primary key is a way to uniquely identify any one entity within that partition. But then otherwise, you can have as many other properties on an entity as you like. So a couple of key things about table storage. This is not a relational database management system, right? This is a NoSQL type of property value store. And what you have in a table is a bunch of entities. We have insert, update, delete, sort of concepts on those entities, and you can also come back and query those. So we have some concepts similar to what you might be used to in a relational database, but this is not a relational database. It's also not a fixed schema. So here, for example, let's say I've got a table that I've stuck some people into. Currently, I've got first, last, and birth date. But if you look at the data here, Wade and Nathan both have date values for their birth date, whereas Nick has a string value for his birth date, right? So the data doesn't have to be consistent of the same type across entities, nor do they have to have the same columns. Maybe Nathan has a favorite sport and nobody else has that, right? In fact, I would say you could have yet another row in here that wasn't even a person. It was a product, right? And so for you as a developer, why would you do that? I don't know. But can you do that? Yeah, by all means. If you want to, stick whatever entities you want to. As long as they have a partition key and a unique value for their primary key, you're good to go. So the question is basically, if I don't want to keep the data up in there anymore, what can I do with it? We don't offer any export tools, but you can query the data. So before you dropped your tables, before you deleted your storage, you could go in and just export the data by querying it, and then write your own sort of XML streamer or something like that. But we don't offer an export utility. Right. No, and there's not ODBC. There's a RESTful API, so you can connect to it from anywhere in the world and query it, assuming you have the application keys. Now, tables are always private. Blobs, I mentioned, you can't have public containers and public blobs. Tables are always private, and so you'll need the client access key, one of those management keys, to be able to hit that, but you could query it and export that data out yourself. Right. So I mentioned partitions and ranges. So here, for example, I see that my partition key is on the category column, right? And so I have bikes and canoes and rafts and skis. Now, they may all be physically stored together. So, for example, let's say inside the Azure Center right now, they're all on storage node A, right, or server A, if you will, right? But as Azure determines that it needs to, maybe it discovers that bikes are, a heavy workload right now or something like that, okay, it's showing me my different subsets there. It could come in and start to, move those off and say, hey, you know what? We're going to move canoes and bikes over to a separate storage node. Now, you don't do that. You don't control it. You don't know when it happens. You don't manage it. You don't see it. But this is something that the Azure Data Center could do behind the scenes, because it discovers, you know what, you're looking at a lot of bikes and canoes right now. To manage that performance, why don't we move them off onto their own storage node to keep that, a consistent performance rate for you. All right. The last storage type then is queue storage. And with queue storage, this is one of my favorite ones. It's a really awesome first in, first out messaging system. And I'm going to demo that if I can actually get myself to switch over to demo mode here, right? But with queues, it basically gives you a way to drop a message into a queue, and at some point in the future, come pick that message up out of the queue and do something with it. This is a fantastic way to build loosely coupled systems, right? You say, well, I want to have a client app that submits something into the cloud. I could point it directly at a service, or I could just drop a message in a queue. And then at some point, I know that my service is going to pick that message up. And that means that the service doesn't even have to be available, meaning the processing service doesn't have to be available at the time I drop that message into the queue. This is guaranteed delivery, first in, first out. I call it first in is likely the first one out. And that's because I could have multiple readers. Somebody might pick up a message and then get stuck processing it. In the meantime, the second message in the queue actually got processed quicker and spit out, right? So you might see that the end result is that they don't look like they're getting processed in order, although they really are being picked up out of order or in the right order. All right, so this is a great way, as I say, to build loosely coupled apps. A common scenario, and we'll do this in our app, in our demo here, is have a web role. It's going to drop messages into a queue, and then have worker roles on the back end that pick the messages up out of the queue, and then go do something with them. All right, so I mentioned that each one of those guys has a RESTful API, and I also mentioned that there's these management keys. And RESTful APIs are really cool. They give me a way to use a standard protocol like HTTP and build a service layer on top of it, right? HTTP has built into it a way to get, put, post, delete data. And there's my CRUD operations, right? Select, insert, update, delete. So REST is awesome for building a data layer. or something like that. The problem that we have with REST is if I want to authenticate it and secure it, I can use HTTPS to encrypt the traffic, but anybody could do HTTPS. How do I make sure only approved clients are there? Well, then we have these management keys. And then I have to like build a hash of the key and create an HTTP header and stick it in the HTTP packet so that I can say, all of a sudden this isn't fun, right? So REST is accessible, and basically everybody who speaks HTTP can participate with my service, but open doesn't always mean easy, right? And so to simplify your life as a developer, Microsoft has created a variety of client-side SDKs. In this demo, I'm using the .NET one that basically wraps up the RESTful API for you in a nice set of .NET objects. So you just use .NET objects, you call methods, and it builds the HTTP requests and does all the stuff for you behind the scenes. So it makes your life a lot easier. So we'll come back in here and I'll demo through that. We'll have my cloud shop let me enter in a product, and we'll drop a message into a queue, pick it up out of the queue, create a table entity for it, sort of round trip the data back there. Cool.